we're looking at the plot contours on shape. So this is a contour plot that we're looking at. So let's change this to Mises again. All right, so there's lots of stuff to talk about. So let's go it through one by one. First, let's talk about, so the colors are representing something, and the values associated to the colors are in this color bar here. So red, high value, blue, low value. This is the standard rainbow or jet color scheme. Yeah, so this is the classical scheme. You will see this everywhere. Yeah, MATLAB has changed it's now, because the new one is actually going from blue to yellow, so that it's going from a dark to a lighter. This old one is going through from, if you just look at it in black and white or in a grayscale. I mean, if you print this to a grayscale paper, which a lot of books do actually, you can't really see anything here because it's going from dark to dark over light. So you don't know if the dark areas are low values or if they are high values. So it's really, really bad to use this scheme and print it in a grayscale, which like all the books ever on finite elements do. So that's why MATLAB has implemented its new parola, which goes from a darker color to a lighter color, which is really good. But yeah, that's out of the scope. I'm just ranting here. I don't know why they haven't implemented this yet. So if you want to change this, you can go to contour options. You can go to color and style here, and you can change this to spectrum. And this is where this stuff is hidden. So you can do black and white here and apply. You can see here you're going from low values or black to lighter values, which are white here. And you really need to do this if you're printing this, and but nobody does that for some reason. I don't know why. It's like really easy to just go here and change. Okay, so you have blue to red. You have rainbow, which is the classic one, and what else is there? White to black could also be interesting. Like if you want to save ink, you have lots of high values but no low values. White to black. Or the other way around, black to white. Never mind that. So change this back to rainbow. Yeah, so those are the colors. So you can see what the colors are representing. Okay, if you go back to basic, and let's actually not go into this yet here. I'll save this for later. Let's talk about the actual number representation here. These are floating point numbers, and this is really fine for now if you have low numbers like this. But yeah, I have low numbers like this because of one reason. This thing here is huge. So you can actually check out the length of this, but I can tell you that the size of this is 100 times 10. And then you are asking yourself, okay, what's the unit? 100 doesn't tell me anything. Well, the unit here is like everything in Abaqus. You set the unit yourself, so you're responsible for handling your units. And right now I've set this to meters, I believe. So I've calculated everything in meters, SI units. So this is 100 meters times 10 meters. And the load is applied here as a concentrated force in the negative y direction. So I'm pointing a load here of 1,000 newtons. So this is extremely low compared to the size of this. And the E modulus is set to 210 to the power of 6. Which is 210 megapascals. So this is steel rod that is 100 meters times 10 meters. It's huge. That's why the stresses are only 2,000 pascals, right? 2,000 pascals. That is what, 0.2 megapascals. Extremely low. So if you want to, usually this would be, I don't know, say 100 megapascals, like, right? So in order to see that huge number, in order to grasp it easier, we can change the numbers here. Go to viewport and go to viewport annotation options and go to legend. And you can see here the numbers box. Now, right now it's set to fixed and the decimal places are 3. So we can change this to scientific, for instance. You can see here it changes. Or you can change it to engineering. And the difference between scientific and engineering is a little bit easier to read, right? Because you can have up to 3 numbers in front of the decimal point. So, for instance, here you can see that this is 2 what? Well, 3, so 2000, and this is 800, so it's just 840, right? So a little bit easy to read, and then you can change the decimal places if you want, down to maybe 1, and it gets a little bit shorter, but yeah, let's keep it at 3. It's quite nice that way. Okay, so numbers. Okay, so this is deformed, but is it really deformed this way? Well, this is what you have to look at, the deformation scale factor. Right now it's set to 1151, which is huge. So yeah, this is exaggerated 1000 times. If you want to change this, you can go to common options, and you see here the deformation scale factor. Right now it's at auto compute, it's 1150. You can change this uniform and set it to 1 and apply. So see here that it doesn't really deform at all. The deformations are extremely small. How large are they? Let's take a look. Go to displacements here, and you can see that the maximum right now is at 8 to the power of minus 3, and this is in meters, right? So this is 8 millimeters. So this thing is bending 8 millimeters. It's 100 meters long, 10 meters big, and it's made of massive steel. So yeah, this is pretty believable. But remember, you have to keep track of your units, right? This is important in Abaqus. It doesn't do it for you. Okay, how about this thing here? It's showing the maximum. We can change this as well. I believe it's in contour options, limits. Yes, it is. So if you go to contour options, plot options here, you can go to limits and you can change these max, and you can select show location on and off here. It will show you the location of the maximum, where the maximum point is. Right now it's showing me this one because, well, there's a constrained force applied there, so of course it's going to be there, but in reality it's not really that high. Okay, so you can specify the maximum here, and yeah, you can change this. It's nice to do it when you have, for instance, stresses, and you can change it to your yield stress, for instance.